Hello, everyone, and welcome to Lecture 1. This is going to be our first lecture for 211. I know last week I didn't post anything, but let's get started. I'm going to try to cover Chapter 1 and Chapter 2. Kind of on the verge of getting sick, so I'll try my best. So if I sound stuffy, that's because I'm not just under the weather. I think I'm about to get the flu. Anyways, so first and second of C and Unix programming. One thing I ought to mention about Unix programming is, even though in the syllabus you'll see uh, Unix programming book mentioned, I don't really assign readings from it. The extent to which you need to look at the Unix programming book is just so you know enough around the Unix world. If you use the terminals at school, um, you should be able to open up a file, close a file, save a file, compile a program, run it. So the assignments that I give you will really help you um, kind of gain more of the understanding of Unix. Um, so let's say, for example, I give you an assignment. Well, take in two integers from the user, add them up, and display the count. Um, well, that's fine and good. But when you actually open the file, write that whole program, save it, run it, you're gonna do it on Unix. So that'll get you up to speed with Unix. And on the final exam, I'll expect basic things from you, from Unix. For the midterms, I don't think there's gonna be anything from the Unix books at all. But like I said, the expectation is going to be there that in order to run your program, do basic commands in Unix, you are well versed in it. So nothing special. I don't want you to panic thinking that there are two books and you have to read both of them. No, it's just one book. And most of the things that we're gonna learn and focus on are gonna be from the C book. Okay, hello world. The the very first program in any language, at least the ones that I teach, is always the Hello World. The book discusses or mentions a different one, but I've been taught the Hello World, and I think it's a great way to learn what a Hello World program is all about. Okay, so this is what the first Hello World program looks like. Now, since it's the first program, you can go ahead and memorize or practice with this syntax. Um, you have an include stdio input and output library.h, and then you always are going to have this int main open parentheses and close parentheses here. Int main is actually the method. It's a main method. um, it's not 93, it's 7. I don't know, this thing's getting this weather for. Anyways, I'll have to change this. um, and printf is a command, print something to the console, and in this case it's hello world, and then to return 0. Alright, so memorize the syntax. We're going to be using it again and again. Okay, so let's continue on. The next thing I wanted, so that was a Hello World example. So the next thing I wanted to cover was variables, expressions, and assignments. All of these three are buzzwords. Variable, as the word suggests, it can be it's a variable. It can change from time to time. Expression, an assignment. You all know what the English meaning of all of this is, but when it comes to C, they have different meaning. Variable is a, you know, when I say int I equals 0, I is a variable that's initially assigned to 0. You can later on assign it to somebody else. And the equals to sign is an assignment. Um, and the types, because now here we're getting into the data types. There are different data types, integer, floats, doubles, strings. Oh, I shouldn't say string. In C string, you'll see it in C++. String is nothing more than an array of characters, but C has characters. Union and so on. And there's so many types that you learn, but I've just included the first few basic ones: integer, floats, and doubles. Um, and the other thing that I wanted to mention is about comments. Comments is something in C, they get ignored. They don't get compiled. Whatever you get in between the comments is for the reader. Uh, the question that comes to your mind and my mind initially at some point was, so if the compiler doesn't do anything, what are the comments doing? Comments are actually there to make your program readable. So somebody comes in 5 years later, he looks at it, he understands what's going on. So people start off by writing their name, when was this program first written, what does it do, and right before complicated logic, people tend to have comments on before a method. Um, if it doesn't make complete sense right now, it's fine. As we get more into the class, this will make complete sense. By the end of it, you'll know. Oh, okay, now I get it. Now I know why comments are important. But it is so important that I come across code that's 5 years, 10 years, 15 years, or even longer, that have been there in the production forever. And over the course of decade or 2 decades, the code goes through so many different people. People make changes to it, and at the end, it's so hard to understand. And this is where comments um, come in handy. I tend to read the comments, and it helps me immensely understand what's going on over there. Just not just looking at the source control and the changes and the code, but why it was done and what's the logic, because the logic can get very complicated. And the business rules might change or anything might happen in years. So it's I cannot stress the importance of comments. Okay, so you should know about comments, you should know about assignments, you should know about data types. Now let's just jump into the second program. Um, one thing I had to mention is I'm not logged into the Unix terminal at the campus. You'll see me tend to use this online C compiler, and now that I've shown it to you, I'll put a link on for this on the website so you guys can also do this. I'm not going to force you to use a particular compiler, a particular terminal. As long as you submit a program that does the job, follows the requirements, I can compile it and run it, and there's no issue. You'll get the credit for it. So this is just something really convenient. This computer is slower, and sometimes when I log into the terminal, it takes a while, and sometimes it goes through something. Well, the other thing is every semester I gotta renew the password for myself and a lot of times for my students as well. And then there are other issues. Not that I'm demoting the Unix terminal because you gotta use it. You have to know it. You're gonna use it for other classes, but it's just a habit that I've been using the online compilers. So, anyways, coming back to this, I have rewritten the Hello World program, made changes to it, and These comments are this is what you can do, and watch the color, right? Um, you can have it as slashes as well. The color is green, right? So if I do this, everything underneath is green because it's waiting to find out where's the end of the comment. There you go, color changed again. So this is the start of the slash star, and then star, actually it says slash asterisk is the beginning of the comment, and then asterisk slash is the end of the comment, and anything and everything in between it is completely ignored by the compiler. Hint: I might ask you this in the midterm or final. Okay, so here I've declared two integers, and the way you go about declaring them is this data type and the name. You can give it anything as a name. Doesn't matter how long or short the name is. There's no restriction. So in this case, I've got number one, number two. Now, when you declared it, what value is it going to have? You haven't assigned it anything. Well, we don't know. Sometimes it might have garbage value in it, sometimes zero, or sometimes no. It depends on the compiler and the program you're working with. I'm not gonna output what the compiler assigns initially, um, but what I'm going to do is the next statement, which is right here, number one equals to one, right? So this integer that I just declared, I've initialized it to one. The equals um, demonstrate the assignment, and number two is two. Then I have another variable, right? These are all called variables now that we know it. Int final number equal to number one plus number two. So the final number is going to hold the total, the sum of number one and number two. And once again, I want to output to the terminal. I say printf, the final number is, and what is this? What is this? Right? Um, D right here, comma, final number. Well, this symbol right here tells the compiler that it's going to be an integer, and that integer is final number. Because if you don't do that, it's not going to output the number. There you go. The final number is 3. Okay, so now I'm going to talk about a few different topics. One is the preprocessor, the pre-processing commands. The pre-processing commands, I'll touch on it briefly. I'm not going to cover examples. It's a little bit more complicated topic. Maybe we'll come back to it later on. Then I'll get into input and output, and then the looping strategy. Okay, if then else also something I'm going to discuss. Now, when it comes to pre-processing, what happens is, C is a compiled language. There is a this concept of compiled language and a interpreted language. So C, the way the difference between the two is, if you have an interpreted language, what's going to happen is, as and when you're typing something, what's going to happen is it's going to get interpreted, and if you make a mistake, error is going to be thrown out right then and there. And the other thing is, when it comes to compiled language, which C is, you're going to have to type up the whole program and then try to compile it, and only then you'll see the errors. There are pros and cons to both, but just know that C is a compiled language. And the way compiler works is, if it sees a pound sign, what it literally does is, this file stdio.h, it copy pastes that entire file right before, instead of this. Okay, so there's a separate file that gets pasted here, and then it gets compiled, and you so the actual compile file is much bigger. So if you say, there's also a define, a so anything, there's a keyword called define, and then you can set a variable to something in this manner as well. These are all pre-processing commands, and they're going to occur before the compiler runs. So the compiler is going to see these two first. Now, okay, so now let's start talking about input and output. You've noticed that I keep using printf quite a bit. So printf is the command for outputting something to the screen. You saw the hello world example, right? And scanf is for input. Now, one of the things for printf that I wanted to get across is, if you've taken any other languages, output is a little bit more simpler, but C is more primitive. So you have to tell it the type that you want to print. Okay. Hello world is simple. We're able to get away without giving it a type. But if you wanted to give it a type, um, you would go about in this fashion, this exact um, manner, right? The slash n, that denotes a new line character, which is a special character. Anytime you have a special character, you have a slash and then the type of character after that. So modulus C, modulus F, and if you want to output a character, you would say modulus C. If it's a decimal, modulus D. E is for floating number in scientific form. F is a floating number. Oh, E is in scientific form, floating number. F is regular floating number. S is string. Now, a string is nothing more than a character array. So in this example, what I've done is I have a float, and then I have a character, and then I try to output those, right? So it says C and then 1.200. It added zeros after it. That's not a big deal. Now, what would happen if I just do this? It's going to complain. It doesn't know what C is. So you have to tell it what type it is. Okay. And the other piece of information is scanf instead of printf. Printf is for outputting to console, and scanf is for input. Let's say if you wanted to take an input from the user, you would go about using scanf. Exact same syntax. Can do Control Z here. Exact same thing, okay? Except the keyword is different. Okay, so that's for input and output. Moving on to the next one is the if then else. Now, the next building block or the foundation for a language is the conditional aspects of it and looping. And now, if you want something conditional, the way you go about it in C is if, and this is the exact syntax, right? If, and then you have a specific condition, and then you execute, then you have in the body the code that you want to execute. And then you have these parentheses in the beginning and at the end to signify that your if only lasts from this, from that's the start of it and that's the end of it. And this is a simple example. If the number 20 is greater than 18, you output 20 is greater than 18. It's a simple, what do you call check? But as you get into more and more advanced programming, these checks are going to get more complicated, and then you'll have to troubleshoot it as well. Okay. Now, the next example here, part of the same program is x is equal to 20, y is 18. If x is greater than y, x is greater than y. Just output it. You go ahead and run it. Right, hello world. We can skip the hello world. Had enough of hellos. 20 is greater than 18, x is greater than y. Forgot to have a slash in at the end, so I had a new line character. But you get the point, right? So memorize the syntax. Well, actually, you don't have to memorize it. The way to go about is getting familiar with this is you do it often enough. You run through examples again and again, and this way you'll get the hang of it. Okay. The one thing I want to mention is you notice this compiler is a different one. You know, the programming one that I used before, and then this one. These two are the ones. I think these are the only two that I'm going to be using throughout the class. And I'll post a link for both of these on Blackboard, so it's easier for you guys. Moving on. So if execute something, but then there's also another way. If else, if, right? So if not this, else that. Otherwise, if not this, else if, and then finally an else. So if you want to have more control over this looping strategy, I shouldn't say looping, in this conditional execution, you can use if condition one, block of code to execute, else if there's another condition, then this block to be executed. Otherwise, at the end, just execute this block of code. So what's going to happen is condition one fails, so nothing happens. Then it checks for condition two. Now, if both of those conditions fail, then it's going to execute this. So keep in mind, right? If first condition is met, it's going to execute this, and it's done. It's not going to execute else. So this is one thing I want you to get a hang of, and understand, is how these if else works, right? If after talking if the first if condition is met and that block is executed, the else is not going to get executed. It's like the way we're talking, right? If this, then I'm going to execute this. Else this, right? So it's a little hard to explain, but once again, you'll have to try it out with a few examples on your own. Now, what I have done in this example, I set the time to 22. If time is less than 10, then I say good morning. If it's less than 20, I say good day. Otherwise, I say good evening. And I run this program. What do you think is going to happen? Good evening, right? It's going to come here. 22 is less than 10? No. Is 22 less than 20? No. So it executes the final output. Now, this time it says good evening, right? Because I changed the, well, I didn't change it yet. Now let's run it. I just took out the hello world. Good day, right? And now you're kind of getting the hang of it. So that's if then else, so on and so forth. And this is, you can have this over and over again. If, else if, else if, else if, else if, for as long as you want. Now, the more if else that you have, it might make the reader more confused. But I'll come to how we deal or make the program a little bit more readable in a little bit. Before, but let me tell you about the while loop. What if you have a condition that for as long as it's met, you want to do something, right? So as long as my condition is met, not to sneeze. As long as the condition is met, I say, hello world, right? Or I do something else. I'll put in an integer, whatever you want to do. But as long as my condition is true, I'm going to keep outputting this. In this case, I do this number, which is I. Now watch what happens. And you're going to exit out of the while loop when the condition is no longer true. So when you come in here, let me run it, and then we'll talk to it. 1, 2, 3, 4. Is 1 less than 5? Uh, my condition is met. I'll put 1. Is 2 less than 5? Yes. Then I go ahead in the body. I do it again for 3. I do it again for 4. But is 5 less than 5? No, it's not. Then I no longer output anything, and then I see this as the output. Next up, I'm going to be talking to you about functions. Now, what happens is when you start writing the code, there are times when you'll see that you're having to repeat the same line of code over and over again. Let's say, for example, you had a situation. You may not, but you have to call this while loop 5 times. So you want to have output of this while loop multiple times. So you'll have the while loop again and again, or some sort of statements again and again. Now, this makes the code, from a readability perspective, harder to read, understand, and also troubleshoot in the future. Like I said, the code that you write is going to be around for a long time. Or the code that you're supposed to read, understand, make changes to will be something that's really old. So the way get around this is the use of functions. Now the way you go writing about a function is uh, the name of the function, and then open and close braces. In the open and close braces, you would give it parameters, arguments, something you give to the function. And this right here is a return type. So try to play around with the syntax, understand it. Return type, name of the function, open and close the braces, parentheses, open and close, and then here is the argument. I've said void because there's no return type. So it says void. If you're going to return an integer, you'll say int, characters, char, so on and so forth. Now here what I'm going to do is, so you see this function, right? There's nothing in the function right now. Okay. I'm going to copy paste this code from here to here. Okay. Watch. What do you think? What? This syntax here. Plus, it should go here. Okay. What happened here? What did I do? Text or return 0. Int main. Oh, yeah, there you go. Okay, now it should compile. The parentheses missing. Expected identifier. This is the while. This is the function. Open and close. Expected. And missing under the parentheses some braces. 27. Okay, so now I've got a function here. Now, how do you tell your program to go to that function? Well, it's very simple. You, it's as simple as that. Now you see 1, 2, 3, 4 is printed again. So all you did in the program was transfer the control uh, to a different place. Now, int I, let's call it int j. You could have done this as well. One thing I wanted to mention about is the call by value and call by reference. Well, the book doesn't mention call by reference, but at some point that's going to show up. The call by value, what it means is, the function has one parameter, which is an integer. Now, when I call the function and send in a number, what actually happens is it's a copy of that integer, not the real one. So, here I tried to assign j to I, but nothing happened. I run it. Look at the end. It's still 10 because it got the copy. If it were called by reference, any changes I made to this integer inside of this function will reflect outside as well.